Hello, and welcome to the Amazon Web Services Partner Webinar Series. Our topic today will feature delivering high-performance and scalable SQL databases on AWS. I'm your host, Sherry Sullivan. I'm here with the Partner Marketing team in Seattle, and I'd like to start with just a couple of housekeeping items before we begin. I'd like to remind folks to submit questions anytime during this webcast using the Q&A in your browser. Also like to mention that we will make today's presentation available on our AWS SlideShare channel as well as our YouTube channel post-event. And I'd also like to remind folks that we are recording today's session. I'm pleased to be joined today by Seth Proctor, who's the Chief Technology Officer with NuoDB. He's one of our technology partners, as well as Ian Marino, who's the Digital Project Manager with NorthPoint Digital. He'll provide us with a NuoDB customer perspective, as well as our own Miles Ward, who's a Senior Solutions Architect with Amazon Web Services. We'll wrap up today with just a few moments of Q&A. So before we begin, I'd like to welcome Seth, Ian, and Miles. Please take it away, Miles.
Thanks a bunch, Sherry. Really appreciate it. Today's conversation is going to be hopefully a useful overview of Amazon Web Services as it relates to the relational database workload. And then I'll be handing it off to Seth, where he can take through a deeper dive into the technologies that power NuoDB, a new kind of SQL database built for the cloud. So to get started with that, I think a lot of this earns a lot of benefit when compared to the context of what it used to take to build high-performance, high-scale database systems. And frankly, that's a lot of undifferentiated heavy lifting. And in the best of cases, it's only very expensive. We've heard from lots of customers over lots of years that building very high-scale, very durable, very highly available data storage systems, structured storage systems, relational, non-relational, SQL, NoSQL, all those different database tools, that those systems require big capital expenditures, that they take lots of space in the data center, that their engineers are the best and brightest out of their group. They spend the very most talented technicians on these problems that all major large-scale businesses contend with. They're also slow. It takes forever to get this stuff done, always seems to fall behind budget. And if anything, that all happens in the context of really an exponential amount of growth of data in these problems. Customers have more data, new data, big data, and all they want to do is be able to extract new kinds of insight and value from that data at an ever-reducing price. And doing that in your own buildings is becoming pretty difficult, particularly when you spend an increasing ratio of that time, frankly, just keeping the lights on. Amazon's presented kind of a new approach to working these kinds of infrastructure problems. We've made it so that you don't have to make an upfront capital investment. You don't have to come up with the millions of dollars that it takes to build these kinds of super high-scale, globally distributed systems. We've also made it so that even after you've saved by not having to pay the money up front, that the actual total cost of these systems is very low, because you're able to build systems that really tightly fit the exact workload that you have and pay only for what you use. The actual running cost of these systems tends to be very, very low. That's made possible by way of a set of infrastructure systems controlled by a RESTful Web Services API, which is a long-winded way of saying we can make it so that your computers can tell computers what to do. And we've set up that system so that it's easy for you to scale up and down. You can add as many compute resources as you need when you need them, and probably just as importantly, you can turn them back off. You only pay at Amazon for the computers that are running. So if you can build a system that grows and shrinks around your workload, you can save big dollars. And because this stuff is all self-service, we've really helped thousands, hundreds of thousands of businesses improve their time to market for these projects. Stuff that used to take just 6 months in procurement now takes 6 hours in the console, and the whole system is up and built. You don't have to take it from us. The analysts and the scientists and the businesses all are voting with their reviews and their articles and their dollars. Amazon Web Services is very successful in this market space. I haven't seen many of these Magic Quadrants with that many inches between us and everybody else, but we are doing a lot to set the standard and lead the space around infrastructure as a service. So part of what's made that possible is a very, very open approach to delivering service value. We support lots of different operating systems. We'll let you program in whatever language you like. We're partnering hard with as many different applications, building what I would call today, in the context of our current presentation, the other way to run relational database workloads. All of that stuff and more runs on top of our cloud within production for thousands and thousands and thousands of customers around the globe. So what do those workloads look like? What are people doing? Well, they run all of the things that you typically use computers to do. They're running their business applications. They're moving their websites. They've got their game infrastructures and social media data analytics platforms and big data systems, high-performance computing, massive clusters of computers used to build Monte Carlo simulations for financial and oil and gas and computational fluid dynamics modeling. Really, very literally, the things that happen on computers in the server rooms, that stuff is happening on AWS today. Each of those different market verticals and workloads is well represented. And in each of those cases, someplace down in the back is a database that stores the real core information for that system. That database becomes one of the core parts of the make or break of the performance and availability of a given system. So we spent a lot of time investing and focusing on database solutions. We've put that kind of system now all around the globe. There are 9 regions around the world today. Regions are clusters of data centers deployed in regional centers to ensure that we have low latency to major customer bases around the world. Those regions offer the same API with the same control tools on the same bill from the same vendor, so that with just a couple of extra clicks, you can move that same infrastructure that you have running in Northern Virginia, and you can have that thing running in Sydney in an hour. Pretty amazing set of services. In each of those regions, we've built a stack of systems tools, from basic building blocks, like we've already talked about, the ability to rent computers by the hour, that's EC2, all the way up through storage services like S3, which holds in excess of 2 trillion objects, handling over 100,000 operations a second today, on a steady state. Glacier, a backup and archival service at a penny a gigabyte, all the different networking services, all of our internal data analysis services, as well as above that the application tier services, things like simple queue service and simple email service and simple notifications. We have an easy search tool. So we've built this whole layer cake of infrastructure components and then management components above those to make each of those tools easy to use. And you can use all of those different tools in the languages that you're familiar with, using either web user interfaces, command line interfaces, or the APIs that your software needs in order to be able to take advantage of all of these systems. Very broad, very feature-complete approach to management of infrastructure for online solutions at scale. We've done a lot of work. We've built a lot of systems in the database arena as well. So Amazon's built not only EC2, the system where you rent computers by the hour, which can run all sorts of different SQL software. We've built software, helped deploy software from Oracle and from Microsoft and MySQL and the whole litany of old school relational databases. All of the major warehouses run on top of us. All of the major open source or closed source NoSQL databases run on top of us. We've also built our own managed service, a thing called RDS, that manages those old school relational database services like MySQL and Oracle 11g and SQL Server 2008, 2012. We've also built and frankly did a lot of the early innovation around the concept of NoSQL services. So we have a managed NoSQL database called DynamoDB. We have the most popular elastic MapReduce environment, Hadoop environment in the world called EMR. And lots of in-memory databases are running on us as well, SAP HANA, Oracle x10, and Memcached, as well as Amazon's hosted version of that, Elasticache. We're adding today, we're excited to partner together with a new entrant into this list, one that I think offers some really unique and differentiated value, our new partner, NuoDB. So we'll talk at length about how NuoDB is built. I want to make sure that you look at how relational databases work today on EC2 so you can see as clearly as possible the differentiated value that a new SQL database, a system that approaches these problems from a little bit of a different perspective, has some unique advantages. So RDS, our system for management of existing database engines, makes it simple to deploy these engines, manages storage for those systems, allows you to pay by the hour, and creates the ability to use replication technologies, synchronous and asynchronous replication, to scale reads for those systems horizontally across multiple instances. So when you do that kind of work, when you let Amazon manage a database system, we take out the big bulk of the kind of junior DBA workloads of installation and upgrade and patch management and backup optimization. We do backups automatically in RDS. All of that kind of, again, undifferentiated heavy lifting is subtracted from the workload time, and you're left doing the high-value work of performance optimization and your own implementation scripting. So we've done a lot of work in RDS to make it so that your backups and recovery processes are automated, that you're hands-off, you don't have any kind of basic work to do. That's something you set at a schedule and we maintain on your behalf. That leverages S3, that big 11 nines of durability storage system that I talked about before. And we also have created our own system for creating high availability with these older engine technologies. So we've built a system called Multi-AZ where we'll build a synchronous replica in an alternate availability zone. Those are the separate sets of data centers inside of our region, so that if a whole data center facility were to fail, a whole Amazon availability zone was to go offline, you still would have access to the database. And that database would be a synchronous copy of the original master. So you can add one additional tier of redundancy. Another way of adding performance redundancy is by adding read replicas, additional instances that use MySQL's native asynchronous replication to add read performance. But you can see in these patterns, like I only get to add one more machine to add write synchronous durability, and I can add up to 5 machines for read scalability. But we have lots of workloads in these systems and others where 1 or 2 or 4 computers isn't enough, and being able to operate in a single region is a pretty significant blocker for some of the more sophisticated topologies. Today, RDS supports up to 3 terabytes of storage and 30,000 IOPS on the primary master node, which is big by anybody's measure from a database standpoint, unless you're talking about, again, some of these true global scale systems that span regions. So together with us today, we're happy to work with the team from NuoDB to look at systems that are bigger, that are faster, that are designed to handle this kind of multi-regional deployment, and are natively built with the cloud in mind. Given that, I'd like to introduce Seth and let him show you how NuoDB works.
Great, thank you, Miles. Yeah, as Miles said, this is really exciting for us. We've been working for a long time with Amazon. We think the infrastructure that's there to build on is just awesome, and it's great to be able to have these kinds of services on demand and have them increasingly distributed around the world to be able to do some really kind of cool, exciting things with databases. What I'm going to do today is talk a little bit about what Miles already alluded to, NuoDB, which is a fairly new database. It falls, I guess, in the new SQL category. It's a database that's been under development for a very long time, but it's only come to market in the last 4 months. So if you haven't come across it, it's because it's fairly new. I hope to get you interested in it today. And what I'm going to do is just kind of talk through what NuoDB is, a little bit about kind of the technology, what it is that we're doing differently, because really what's really critical, I think, and what's exciting about a lot of the kinds of technologies you can build today in something like Amazon is that you really need architectures that understand how to work with these kinds of new facilities and at this new scale. So we're going to talk a little bit about the architecture of NuoDB, why it's able to exploit something like Amazon Web Services so effectively, and what it is you can do when you pair these two technologies together. And then at the end, I'm going to give you just a little bit of a walkthrough on kind of how to get going if you want to actually get into Amazon and start running NuoDB and see what you can do with the product. So at a very high level, what is NuoDB? I describe it as a relational database that's designed to be cloud scale. I think most people on this call probably know what I mean by relational database. I mean, this is a true SQL relational transactional database. It speaks all the standard SQL syntax, SQL 92 with 99 extensions, a number of additional features from other databases that we think are interesting. It's truly ACID. It's always durable. It's really transactionally consistent. It has the isolation levels you expect from SQL. It does all of those kind of familiar, powerful things that people really want. What's exciting about it is the cloud scale part. And that's really what we're going to focus on today, is what it means to be cloud scale and why the world needs kind of a new kind of relational database, why the existing databases out there are not what I would classify as cloud scale. Cloud is kind of an amorphous term, and certainly cloud scale is an even more kind of hand-wavy thing. So let me explain a little bit about what I mean here. I think increasingly when people think about running in a cloud and they think about scaling in a cloud, they're thinking about a couple of things. Primarily, I think everyone cares about being able to scale out. And really that means doing what you can do so well on Amazon. I can start with a single instance, and when I need more transactional throughput, when I need to be able to handle more clients, when I need to be able to do more processing or go faster, I can just add more instances. I can add them on demand, but I can just add more instances. And that's very different than the traditional database model of 30 years, where if you needed to be able to handle more load or more simultaneous transactions, you'd get a bigger machine, but you'd get a single bigger machine. And I think to most people that's kind of the most important element of being cloud scale. But I think cloud scale is many other things too. So I think part of what's really important is what people see in Amazon, which is that it's not just about adding more resources, it's being able to add them quickly and on demand as you need them. And so being cloud scale is also about agility. It's about being able to react to sudden spikes, to sudden demand. It's about being able to always be available. And sometimes that means having things pre-provisioned, and sometimes that means being able to react, as Miles described, to one data center going down and already being ahead of that and being ready to start working in another data center. And when there are failures, and in a distributed world there always are failures, and they can be pretty nasty, being graceful in the face of those failures and knowing how to respond quickly and knowing how to respond in an always consistent state. Being able to do all of those things in a large, complicated system also means that the software has to be easy to work with. The more complicated an architecture gets, the more moving pieces, the more components, the harder it is to keep track of everything. And so I think the software fundamentally has to become, while the architecture becomes more complicated, the user experience has to become increasingly easy for people to actually be able to work with the database and get their job done, which is not managing a database, it's writing applications, it's serving web pages, it's working with your data. And that's not just the user experience, that's also has to do with how data replication is done, how the system is managed as a whole, how developers work with it. All of these things are really critical. I think Cloud Scale also says a lot about needing security, it needs geo-distribution, it needs a lot of other features, and these are things we'll talk about today. So some of the features that NuoDB offers to address these. NuoDB is an elastically scalable database, and that means that it is a database that scales out. You can start on an instance, you can start on a couple of instances. As you need more transactional throughput, you can bring new hosts online on demand, and you can scale out your database. And that also means that you don't have to think about sharding in your architecture. You don't have to think about any special pre-configuration. We'll talk in a couple slides about how it's really a pure peer-to-peer model. But really, that's one of the powerful features of NuoDB, is that it is a very simple process-based peer-to-peer model. There is no master, there is no central point of failure or central coordinator. And so it really addresses some of those points of agility, but also about availability. It works off of a notion that in nature is called emergence, which is kind of the notion of a flock of birds. There is no bird that's controlling the flock. There is no bird that's telling it when to turn, when to land. The flock knows how to fly on its own, and birds can leave the flock, and the flock continues to fly, to work together. And that's really the design of our database. Another really important feature is something that Miles talked about when he was talking about AZ features in Amazon. Increasingly, people need to work in more than one data center or more than one physical region, and that introduces a lot of complexity in handling data availability and data replication. And so one of the really important features that NuoDB brings is a model where data is always active, it's always replicated, and that makes it easy to scale out, it makes it easy to work between regions. It also means that you never see downtime when you have to think about doing upgrade or migration or when you lose a data center. We make all of that easy for you so you can focus on writing your applications, not on how you replicate data or how you program to an increasingly fragile environment. And then finally, one of the really important features for using NuoDB in Amazon is that we have kind of first-class and integrated management model, so that it's not just about the database, but it's also about the management model, it's about the provisioning model. So it's kind of throughout the stack how to get the software running and how to work with it easily. And this picture kind of gives you a very high-level view of how we think about the system. NuoDB is not a piece of software that's tied to a particular cloud infrastructure or a particular OS. We'll run on Linux, on Windows, on Mac. We run on Amazon and other cloud environments. We can run on virtual or physical. And we really are a scale-out architecture. You can just bring a host online, more hosts. They can be intermingled. You can have some Windows systems, some Linux systems, some Mac systems. You can have some things running in your physical data center and other things running on Amazon. We're very flexible in that sense. And basically, you can think about our software as breaking down into three tiers. There's a management tier, which is what lets you actually keep track of everything that's running, which lets you actually start and stop processes, move things around, react to failure, monitor. We'll talk about kind of some future features in a few slides. And then there's the second tier, which is the transactional tier. And that's the tier that if you're used to writing database applications, that's the tier that you're used to interacting with. That's the tier that knows how to work with an SQL client. We have strong support for Java and JDBC and Hibernate, for C++, for ODBC. We have a pure .NET driver that supports Link and Hibernate, Link and Entity, Ruby support Active Record, PHP, PDO, Node drivers. So there's a wide variety of languages that you can use to program to our system. And then we have the storage tier. And the storage tier and the transactional tier work together, but they're independent, which means that unlike in a traditional database where you're really thinking about the database as a single component, we think about scaling the transaction tier as separate from scaling the storage tier. So if you need to think about more transactional capacity or higher availability from a transactional point of view, you should be able to think about that separately from where you're putting your data, how many independent copies you want. And in fact, in our system, storage is very flexible. So storage can be done against a local file system or maybe EBS if you're in Amazon. It will work against S3 as well if that's what you want to use as your backing store. Out of the box today, you can also use HDFS if you want to write to a distributed store. And there are other storage mechanisms that we'll be adding in the future, and I'll talk about that a little bit later. In terms of what a database looks like, this is part of what's really exciting about NuoDB, I think, because a database is made up of these transaction engines and storage managers, these processes that know how to do transactional processing and know how to do storage handling that are distributed across any number of hosts, but appear to a programmer as a single logical database. And so what I've drawn in this picture is 6 hosts that I've provisioned, and they're supporting 3 logical databases. But those databases have different characteristics. Some of those databases are more highly available than others because they have more processes available for doing transaction handling. Some of these databases have more independent points of storage. Some of them are storing to the local file system. Others are using S3. And what that means is that as you need to be able to do data migration, or as one host fails and you want to react to that by bringing another host online and getting right back to your data, obviously storing in something like S3 or HDFS makes that much faster, makes that much easier to work with. But the important thing about all of this is that it's really it's from the point of view of a developer, from someone who's a JDBC developer or someone who's a Rails developer or someone who's a PHP developer, what you're really seeing is what looks like just a traditional database. And I can bring more transaction engines online on demand, I can move where they're running, and I continue to see just a database that I'm programming to. How do we do all of that? I think there are a couple important key architectural aspects of NuoDB, and I have to apologize ahead of time because the hour that we have here to talk about is not nearly enough time to go into all the detail. But at a high level, I think there are a couple architectural elements that enable all of this. And so the first one is this notion of the separation of the transaction engine and the storage manager. And in particular, the transaction engines in this case are entirely in-memory processes. If you like, they're the part of the system that know how to do the A, C, and I in ACID. They know how to maintain atomicity, consistency, and isolation, but they have no idea about durability. And that has a lot of nice properties in terms of failure handling, in terms of migration, but it also means that our transaction engines are caches, which means that you don't have to think about layering any additional caching layers. You don't have to think about how you keep things in memory. You're already working entirely with in-memory data sets. Importantly, though, these aren't replicated caches or case-safe caches or caches that require all of your data to fit in memory. They're just very simple, lightweight, on-demand caches that pull the data in as needed and can drop data when it's no longer needed and do some very efficient and intelligent things in the background to try to maintain those caches as efficiently as possible. Decoupling what's in memory from what's on disk is part of what we do that's architecturally very different from traditional databases, something like an Oracle or a MySQL or a DB2, which are very powerful, very cool databases. But when you squint, they're really kind of grown-up file systems. They're really working very hard to keep things in memory in a form that maps very well to something on disk. And that, in a distributed world, means that you have a lot of limitations. You're very much limited in terms of I/O rates. You're very much limited in terms of how flexible you can be in terms of scaling the transaction tier. And that's part of what we've done is really decouple these concerns so that you can really scale very efficiently and you get much higher performance with much lower I/O, which in a cloud environment, needless to say, is really critical to scaling effectively. The second kind of key architectural concept I want to highlight is the way we handle consistency in our system. So a traditional database might use something like a lock manager or a deadlock detection algorithm, and these are very powerful, very important technologies, but they don't scale when you start to scale out and think about a large distributed system. And so we use something called multi-version concurrency control, which is basically a way of thinking about all data in the system as versions. And when you're making a change, when you're deleting something, you're inserting something, you're updating something, all you're doing is creating a new version of something. From a distributed systems point of view, this has a lot of very nice benefits. It really simplifies things. You can think about the database effectively as an append-only system where you're just constantly creating new records, or just new diffs even with versions, which means that the messaging is very simple, which means you can often batch messages and be very efficient about handling batch messages as kind of single writes rather than lots of independent updates. It also allows for a high degree of asynchrony and optimism because a given transaction engine, as it's driving transactions, can handle multiple different versions of objects. And so you're not really updating something in place, you're just keeping track of the canonical version of data as well as how data is changing. And so this means that very rarely will a commit in our system be gated by kind of some synchronous round-trip message. And it also means that as we think we're making updates, we can start sending out messages to our peers. That leads in a cloud environment to very high efficiency because it means that when there are sudden network spikes, when there are dips, when there are drops, we're not nearly as affected by those as a traditional system because everything is very asynchronous. And typically, the running time of a given transaction is going to mask most of that I/O operation. And that's part of why we scale so effectively in an environment like Amazon. The third really key architectural concept I want to highlight is this notion we have of what we call atoms. Atoms are basically the structure of data in our system. Atoms represent objects. All of the data in our system is structured as just very simple objects. There's really no view of SQL structure at all. What that means, among other things, is that when we're making these updates and when we're sharing information, what we're really doing is just changing structure around shared objects in a system. And so our storage layer is really just a key value store. And that's why we can use something like S3 or HDFS or address any number of other key value stores. And obviously the industry has spent the last several years building really powerful key value stores. And Miles talked about a few of those, things like Dynamo. And so we're very well suited to work in an environment like Amazon where you have very powerful, simple mechanisms for doing storage and have that key value store separated from the part of the engine that's actually doing transaction processing. And again, I apologize, that's a really quick run through for something that I'd rather spend several hours being able to dive into. So I'll provide some follow-up links after this. And if you have questions, please don't hesitate to get in touch. So I just want to go through and highlight kind of a couple of the things that I alluded to right there in terms of why I think NuoDB and AWS are such a good match together. And first of all, there's really this question of ease of use. I said earlier, I think part of what being cloud scale means is really being something that's easy to work with. NuoDB and Amazon both build off a very simple provisioning notion, a notion that what you do is you bring an instance online. You bring an instance online with some base configuration and some base software installed, and that's kind of a way of getting bootstrapped and from there being able to work with a system. And that's the NuoDB model, is we have a very simple model where you can bring an instance online, either just a vanilla instance through Amazon or something through the marketplace. We are available today in the marketplace. I'll show you a demo of that in just a minute. So you can very quickly bring Amazon instances online that already have NuoDB provisioned and available so that you can start running one or more databases across your instances. We've also worked with Amazon to provide PIOPS guarantees. And in addition to providing CloudFormation, we also include with our distribution kind of simple examples for getting going if you want to do a custom deployment, if you want to use something like kind of standard Python interfaces, scripting interfaces to talk to Amazon to bring instances online, to deploy NuoDB and start working with the database. We've also worked really hard in terms of out-of-the-box management. So if you're not a hardcore DBA, if you're not a hardcore database developer, but you want to get working easily with our system, we have some really nice, simple web-based interfaces to work with the product. We also provide scripting interfaces, and we have that all tied into a nice kind of central point for seeing demos, doc, support discussion, things like that. And we also have support built into our product for being able to map network boundaries in Amazon. And so whether you're talking about working between regions or whether you really want to support database components inside of Amazon as well as outside of Amazon. Say you want to run a database inside of Amazon, but you want to keep a complete independent archive of your data on premise. You can do that by simply starting a process locally, and it will connect to your database running in Amazon and always stay synchronized. The second feature I want to highlight really is this notion of high availability, and Miles is exactly right. Part of why people are excited about something like Amazon are availability guarantees, and that's certainly part of what we're trying to provide that I think is really critical. I already described kind of our very simple model. We can, we work by bringing new instances online, having them available, and then simply starting processes to expand. So you can start new transaction engines to get more transactional throughput. You can start new storage managers to get additional points of data redundancy. It also means that reacting to failure is simply a matter of saying, I lost one host, I need to start a transaction engine on another host. And in practice, starting a transaction engine is measured on the order of tens of milliseconds. So it's a very fast, very reactive system where you can either have resources pre-provisioned or you can bring resources online on demand, and so you can really maintain high availability. Because we have this in-memory model for transaction engines, doing things like migration from one host to another or doing upgrade is something that we can do very efficiently. And in fact, we run regular tests here where we do complete deployments and then complete live upgrades from one version of the software to another without any loss of availability. And I think that's a really powerful, important feature in today's cloud environment. And the last thing I want to highlight is this notion of geo-distribution, which is something that I think is becoming increasingly important and something that NuoDB provides today and something that we're working very hard on for our next release, our 1.2 release. Everything I've been talking about today, the ability to think about running a single logical database, even though it's distributed across hosts, works in a single region in Amazon and also works across regions in Amazon. And so the same tools, the same development model, the same software that lets you get a NuoDB database up and running will let you, say, run a single logical database with processes in Virginia and in Oregon and in Hong Kong. And we can make that run efficiently. We can make that run with high availability. Data replication is done automatically. Data is always consistent. And so you get a lot of really nice guarantees with no additional work. So all of those steps that Miles was talking about earlier in terms of supporting being able to do replication and making sure that you have data available and knowing how long it takes for updates to propagate through copies, all of that disappears in NuoDB. It's just a very simple automatic model, gets you productive, gets you running in a geo-distributed environment. And I think probably the easiest way to show you a little bit about what I've been talking about here is I want to do a quick demo. I have a 5-minute kind of pre-recorded video, and I recorded this because we're going to put this up on our blog right after this call, so that if you want to go find this and walk through it at a slower pace and see what we were actually doing, we'll make it available. Let me just pull up the screen sharing software here. What I'm going to show you here is basically the steps involved in getting going, provisioning our software on Amazon using the marketplace, using CloudFormation. So there are a couple steps involved. And if you've used CloudFormation before, you know about this. The first one is to go get our CloudFormation script, which we provide on GitHub. And the CloudFormation script is basically a recipe for saying, here's how I can bring multiple instances online simultaneously and make sure they're all stitched together with the right security properties, with the right networking settings, with the software already provisioned and installed. So I don't have to think about all the basic pieces. I can just get up and running. So the first thing to do is to download the CloudFormation script. Once you have the CloudFormation script, the next thing to do is to go into the Amazon Marketplace and look for NuoDB. So we're available, as I said, on the Marketplace, and you can go in and you can see there are different versions, but we just released our 1.1 version about a week ago, and that's now available in the Marketplace. And if you go into the marketplace and you say launch with EC2 console, but instead of launching a single instance, you just say accept terms, what you've now done is you've subscribed to that AMI. And now that you subscribe to it, you can use Amazon's CloudFormation to automatically bring up multiple instances that are all working together. So you do this by going to the CloudFormation interface and saying, I want to create a stack. You can give it whatever name you like. And then you upload that template, that script that you downloaded from our GitHub site. And all the links are available on our blog that will be referenced again, so you can find this and walk through this kind of at your own pace. And then what we do is we ask you a few very simple things about what you want your NuoDB environment to look like. How many hosts do you want besides kind of a management point? What do you want to name your domain? And we ask you for an administrative username and password, the SSH key to use, and then that's it. It'll take a few minutes. It will start actually running through provisioning things, make sure the security properties are set up correctly. If you're interested, you can follow along in Amazon's console here. You can watch the events. And after a few minutes, all the instances will come online. All the NuoDB software is running, and you can see that because you get to that create complete step. So at this point, among other things, you have a host running what we call a broker, which is a management point basically for being able to connect to the system and see everything that's happening, start databases, stop databases, monitor databases. And so the first thing you'd want to do is go in and find that thing tagged NuoDB broker, find that URL there, and go to port 8080 on that host. And this is all configurable. This is just what I'm showing you is kind of what you get by default out of the box. And what you end up with is our web console, our kind of central point of administration, management, and learning about the software. And so now you can use that administrative username and password that you defined earlier to log into our web console. And what you'll see is that you have 4 hosts provisioned on Amazon. We're not running any databases yet, but you've now got 4 hosts where you can actually start running something. In that same web interface, we've got a couple demos built in. One of them is this thing that actually was modeled on the Amazon shopping experience. And so it's a simple way of getting going, kind of kicking the tires, modeling different kinds of customers, and just starting to drive load to the database to understand kind of how it works and how your data might be structured. And so in this example here, I'm just starting to drive some load to a running database on, and this was all done live on Amazon. So now if we go back to the administrative console, what you'll see is that we've got a single logical database running. It's called Storefront, and it's made up of 2 processes. We have a storage manager for handling durability of the data, and we have a transaction engine that's what is actually doing the transactional load. And if I want to expand that, it's as simple as saying, clicking on the Add Process button, picking which host I want to expand to. It will start the new transaction engine, and now we've gone from a single host that can handle transactional throughput to 2 hosts that can handle transactional throughput. And so if I want, I can kind of crank up the activity at this point. In this demo, and what we'll see back in that administrative console is we'll see that load has started going from just a single transaction host to 2 transaction hosts. So just like that, we actually doubled transactional throughput, basically. As I mentioned earlier, just to show you here, you can also run across regions. So here's a different setup I have where I actually have hosts running in the Oregon data center as well as the Virginia data center, and where I'm running a single logical database that from a programmer's point of view really presents itself as a single logical database, but is actually made up of multiple processes. In this case, 2 transaction engines and a storage manager in each region, which gives you high availability and also gives you a lot of flexibility in terms of handling East Coast and West Coast customers. Built into our web tool is also this thing called the Explorer, which lets you just walk through what's in a database. And as you can see here, when you're working with a database, in addition to data, there are a number of internal kind of system tables that you can use. So as you're starting to expand out and work in different regions, you have the administrative view, but you also have an SQL point of view if you want to be able to see that same thing we were just looking at, all the different hosts that we're running, provision and where they're running. So we give you a great deal of power just out of the box in terms of being able to expand transactionally, being able to be elastically scalable, working across regions, and doing administration either visually through our command line tools or at the SQL layer if the SQL layer is where you feel more comfortable doing administration. Just going back here to a last couple of slides, just in terms of where we are today, as I mentioned, we're in the marketplace. This slide actually is already out of date. Our 1.1 release that we shipped just a week and a half ago is now what's in the marketplace with PIOPS guarantees if you'd like. As I mentioned, we have that CloudFormation script available on our blog. We're posting other examples there to kind of help you get started, and we'd be happy to get some discussion going there. And as I mentioned, if you'd rather not go through the marketplace, if you'd rather download our software and do kind of direct provisioning, we have a number of examples available out of the box for that. Some of the ongoing work that I think people here will find interesting, we're working now this is a good starting point. I think, as Miles said, we're very excited kind of where we are, working with Amazon. We're working on tighter integration, working with the Amazon features around load balancing, auto-scaling, configuration. We're also working within our product on some pretty powerful features around handling network partition, around how we support a number of additional languages and frameworks, both from a management point of view and an SQL point of view. And then also something we're working on is increased automation, so that the view of the world I just showed you, where you're thinking explicitly about starting processes, is increasingly in our roadmap going to change into a simple notion of saying what I want is I want my database to work the way I already work in Amazon. I should think about service level agreements, guarantees, quality of service. I should be able to specify that I want a database that doesn't cost me more than a certain amount, that gives me a certain number of transactions per second, that handles a certain number of clients, and has a certain amount of guarantee in terms of failure, and our software will just make it happen. And if you're interested in learning more about that, you should come back to our tech blog, where we'll be discussing a number of those kinds of features over the next month or two. I think that's going to be really exciting. Beyond that, we have a dev center where we talk about kind of all aspects of the software. We have documentation, we have samples, we have discussion forums. And if you have questions, feel free to send us email, info@nuodb.com. I'm sorry that was such a quick overview, but I hope that was kind of an interesting glimpse into what we're doing. And to give it a little bit more context now, I'm going to hand it off to Ian Mariano to talk a little bit about kind of a customer experience actually working with our software. So Ian, go ahead.
Thanks, Seth. That was great. Even rapid, but a lot of information. So we at NorthPoint have a number of customers, large clients that also work with AWS and are very interested in how they can solve their problems with how they use databases in a large-scale environment. So a little bit about NorthPoint. I'll just kind of gloss over myself. We are a consulting firm that is based in New York City with satellite offices in Boston as well as Philadelphia. We primarily focus on two forms of clients. Some are financial services, and some are what we call digital, which are content media companies that are interested in our services. So we were founded in 2003. Like I said, we have offices in New York, Boston, and Philadelphia. We have 150 employees, and this is our general focus around what we do in the digital strategy group, which I'm part of. We have some very large clients, as you can see here. Two notable clients here is Shaw Media, which runs on AWS, as well as Car and Driver, which also has a very large AWS implementation. So a lot of our customer needs around databases are addressed here. So a lot of people have a concern around how do I mitigate this database single point of failure. So NuoDB is very exciting here because its architecture inherently takes care of this, and coupled with what AWS provides, it becomes almost thoughtless. There's no complicated replication to take care of. The data is just there. So this has been very exciting for a lot of proof of concepts we've been doing with some of our clients. Another thing that they're concerned about is how do I scale my database? How do I do things elastically so that I'm not overdoing things or underdoing things? So again, to preface this by looking at other slides that happened before, NuoDB is elastic by nature. by using some of the techniques that are for HA that Amazon recommends and we recommend, using auto-scaling groups, CloudWatch, and custom AMIs to customize your NuoDB deployment. This allows you to do that scaling elastically whenever you need to, and whenever you feel like you need to bump it up, it can be done automatically. You can add instances very easy, change what your instances are doing, as Seth had done. If you need even more HA, you can go the multi-AZ route, which Seth also demonstrated, as well as the multi-region without sharding. Now, this is very important for a lot of our larger clients, is because there's no complicated replication setup. There's no complicated application development that's necessary to have a very large-scale database and have it available across multiple geo regions. Another great thing that we've been able to kind of get into the proof of concept, as well as address the needs of our developers, as well as the developers that are in-house with our clients, that they can leverage knowledge that they already have. It's 100% SQL 92. This is a big deal, because you can use all the skills that you have gained over the years and just use them in a much more available, scalable database. You can also leverage your frameworks and your languages that you already know about, and without having the need to know how to code to scale. Again, a lot of larger implementations, there's a need for sharding, read replicas, and so on. This is something that the application usually has to take care of. It's not an easy thing to do out of the box, but NuoDB mitigates that. Going back to some of the things that both Seth and Miles said, operations. It's a near zero admin and a low learning curve to do the operations. You can set up NuoDB very quickly locally, as well as in AWS, and automate it very quickly with examples that are given there. So we've done a lot of work with scripting our large clients, and the scripting that's involved with NuoDB is very, very almost trivial by comparison for some of the larger clients. So what this all means to us is to be able to provide a better return on investment in what our clients are doing with databases and what they're looking for with databases, because it dovetails quite nicely with AWS, NuoDB. The operations costs, they're significantly lower. Imagine running several MySQL masters across zones, as well as read replicas and so on, and maintaining that with your database team and IT team. That becomes a lot less of an overhead and a lot less cost, man-hours-wise, as well as equipment-wise, when you're using something like NuoDB coupled with AWS. And then what we've also found is very exciting is the speed to market that the development cycles have. So you can just use existing knowledge and focus on features and not how to scale them. So these are things that we found are very, very exciting for our clients, as well as for our own internal applications that we develop at Northpoint. So Sherry, I'll turn it back to you. Thank you.
Great. Thank you, Ian and Seth and Miles. A great overview and a demo of the NuoDB. We've got a lot of questions to get to, and I just want to assure folks, if we don't get to your question verbally, we'll follow up with you offline. So I'm going to kick off a couple of questions back to you, Seth. The first question is, does adding new nodes require time to seed that node to an initial state of operation? An example is like replicating the data, or is the node available immediately?
That's a great question. The node is available immediately. So as I mentioned briefly, this notion of transaction engines being caches but being on-demand caches. And that means that when you bring a transaction engine online, there's not a lot of explicit data that has to be brought into a cache. There's also, because we're not doing any sharding, there's no kind of reshuffling or rehashing or reorganizing data. Really all that has to be shared is a single root atom, one of these objects I talked about, that transaction engine can then use to discover all the other information it needs. And so in practice, when we measure it, usually it's about 50 milliseconds on Amazon from the time I ask to bring a new transaction engine online to the time that it's available and actively servicing new SQL queries. So it's very efficient, and it also requires no special configuration. It's really as simple as the demo I showed, where it's just clicking a button or running a single command line and saying, I want to bring a process online. There's no special configuration, nothing you have to do on the local file system or properties. You just bring it up and you're good to go.
Very good. Thank you. The next question we have, and again, I'll point this back to you, Seth. How does NuoDB handle failover and any potential for data losses due to failover?
No, and that's a really important question. One of the things we're really passionate about here is that a true ACID database must always be consistent. It must always be durable in a known sense, and part of what we get from decoupling that transaction and that storage tier is a notion that if something fails in an in-memory process, it can only fail in a state where the durable data is still consistent and always correct. And so we work very hard to make sure that there is no ability for a host to go down or for a process to fail or for anything else to happen so that the data is in any way corrupted or in any way in an inconsistent state. We would never acknowledge a client commit as being successful if that data wasn't really made durable and we weren't protecting it. And that's true whether you're working in a single region or between multiple regions. That's even true if you're in the middle of doing a rolling upgrade and so you're intentionally bringing down some processes and bringing up new processes. And unfortunately, actually proving what I said takes a long time and a lot of time in front of a whiteboard, so I apologize to the person who asked that question that I can't substantiate it, but if you'd like to mail me, I'd be happy to walk you through more detail, or you can check out our tech blog where we've actually talked about this topic in some depth.
Okay, terrific. Miles, anything you want to add to that perspective about failover?
No, I mean, I think a big component of being able to accommodate those failover conditions in a way that's operationally sustainable is having access to additional capacity when you need it, right? So even if you can start transaction engines very, very rapidly, there have to be computers there to take care of them. That's one of the benefits of running something like this together with AWS is that we can bring the computers when you need them as well. Cool.
Very cool. All right. I think we've got time for one additional question here. There's a lot of questions around transactions. This question is, if I have the transactions are in memory, then when does it commit to the data? So basically you're saying, do I have any chance of stale data in memory data?
Right, and that's a really important question. One of the things, since I think we only have about a minute and a half, I'll provide the really quick answer, and then I'll point people again back to the tech blog where we've talked about this one. But one of the really important things is that in a traditional database, as well as in a modern database, people really want a lot of flexibility over what it means to commit. Different databases have different durability requirements. Some databases, you're not working with particularly sensitive data. You really care more about performance. Other databases, you're really paranoid. You want to be very careful. And so we've worked very hard to make the notion of what commit means very flexible. And so that might mean that you have to have all of your peers in memory acknowledging something. That might mean that you require one of the storage managers to acknowledge something. That might mean you require multiple storage managers in multiple regions to acknowledge something. Acknowledgement might mean that it's written to disk. It might mean it's written to the local journal. We provide you the ability to decide how stringent you need the commit protocol to be. But that said, we would never allow a commit to happen and an acknowledgement to go back to a client without ensuring that these commit requirements are met. And because we have this very flexible, highly optimistic asynchronous model, typically getting very good guarantees around what commit means in terms of durability and persistence is usually not at the cost of particular I/O performance. And that's one of the really nice benefits of the architecture we have. But we do give you flexibility. There's never, ever the case where you can end up with something that is stale, with an inconsistent view of the data, or with a commit happening and somehow the data being lost or corrupted. That's something that we're really passionate about, and that's an important part of our model.
Fantastic. Well, Seth, great job, Ian, as well, from bringing the customer perspective, and Miles for giving an overview of AWS. On behalf of us, all of us, I'd like to thank you for joining us today. and ask you before you log off, if you'll just take a quick survey. We appreciate your feedback. We do read it, and we realize that you've got a lot of technical questions, and folks from NuoDB and Amazon will be happy to get back to you and answer your questions specifically. So thank you again for your time, and have a great evening or morning wherever your day is.